Section 1.4, Part A is on slope and rate of change. Slope is the measure of the steepness of a line. To read slope, imagine traveling across a line from left to right. And lines that have positive slope are increasing. So like this line right here is increasing from left to right, it has a positive slope. Lines that are decreasing have a negative slope. Again, this line right here, if you read it from left to right, it is decreasing, so it has a negative slope. Horizontal lines have slope equal to 0. So as you're increasing from left to right, there is no vertical change, a 0 vertical change. And vertical lines have no slope. So no slope is not the same thing as a 0 slope. Another word for no slope is undefined. And we often use the word undefined to really emphasize the fact that it's not the same thing as 0. And again, a vertical line has only vertical change, no horizontal change. Okay. Let's look at the next page. There are two methods on this page for finding slope. The first one is a ratio of rise over run, where rise is the vertical change and run is the horizontal change. We're going to use this definition in example 1. Okay. Example 1 says we've got a truck driver who has to choose between pass A, which has a 20-foot climb for every 150 vertical feet, and pass B, which has a 15-foot climb for every 160 feet of horizontal distance. So the steepness, often called the grade of each pass, I need to compare these things. The steepness is going to be the slope. So I want to calculate each of these. So for pass A, the slope is going to be the ratio of vertical rise over horizontal run. So for pass A, it's going to be 20 over 150, which would reduce to the fraction 2/15. And pass B is going to be a 15-foot climb over the 160 horizontal change, which would reduce to the fraction, who divided by 5, would reduce to the fraction 3 over 32. Now, it's a little bit harder to compare two fractions than it is to compare two decimals. So we're going to go ahead and convert those both to decimal to decide which of these is steeper. So we're going to look at 2 divided by 15, which is 0.13 repeating. It's 0.133, etc. And we're going to look at 3 over 32, which is 0.09375. Okay, so it is clear that the pass A is steeper, so the trucker is going to want to choose pass B, given that pass B is less steep. He wants to not tip, so he wants the path that is going to be less steep. That's the route he should take. All right, the slope is a lower number, therefore that path is less steep. All right, the second method for finding slope, there's a formula, y2 minus y1 over x2 minus x1. That's calculating the change in vertical distance by subtracting the two vertical coordinates over the change in horizontal by subtracting the two horizontal coordinates. I'm going to point out right now that slope is often represented by the letter m. So you'll often see this formula written as m equals y2 minus y1 over x2 minus x1. And we use the letter m mostly because we can't use the letter s because s's and 5s look very similar, especially if you've got sloppy handwriting. Okay. So I'm going to use this formula to find the slope of the line through these two ordered pairs. Okay, so my slope, or m, is going to equal y2 minus y1. So if I have these two ordered pairs, the first ordered pair is ordered pair 1, the second ordered pair is ordered pair 2. So y2 is the y from the second ordered pair, so that's 4, minus y1, the y from the first ordered pair, which is negative 2. over x2, which is 7, minus x1, which is 4. If I simplify this, this becomes 4 plus 2, double negative there, over 7 minus 4, which is 3. So that becomes 6 over 3, which becomes 2. So the slope or m value of this line is 2. Okay, let's go on to the next page. In example 3, I want to find the slope between these two ordered pairs by both methods, first graphing and using the rise over run, and then by using the formula. So we're going to compare these two methods. So the first, using the graph, I would need to graph these 2 points. So negative 3, comma 4. I think that's about right. Over 1, 2, 3 backwards, up 1, 2, 3, 4. And then positive 3, down 5, positive 3, negative 5. And I need to connect these to see the line formed by these 2 points. So what I'm looking at when I'm looking at the slope between 2 points, the slope of the line that would connect those 2 points. Okay, so if I want to count rise over run, I'm going to imagine a triangle right here that goes straight down, straight over from the first point to the second point. So I'm going to count the rise, which in this case is a fall, would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So the rise is negative 9, and the run is 1, 2, 3, 4, 5, 6. So the slope in this case would be negative 9 over 6, which reduces to negative 3 over 2. So that's by using the rise over run method. Okay, and I'm going to do the same thing using the formula instead of using my graph and counting the rise and the run. Okay, so by formula, slope, or m, would be equal to y2, the second y coordinate, which is negative 5, minus y1, the first y coordinate, which is 4, over x2, which is 3, minus x1, which is negative 3. So that on the top, negative 5 minus 4 is negative 9. On the bottom, I know that my double negative is going to create a positive. This is going to be 3 plus 3 is 6. I'm getting the same thing. I'm not surprised by that. This reduces once again to negative 3 halves. Okay. So when I am doing the subtraction of y2 minus y1, that's actually doing the counting for us to figure out the distance, the vertical distance between those 2 points, and the same for the horizontal. So you can see how the formula works. So the slope between those 2 points is negative 3 halves. Okay. The next definition here is about rate of change. Rate of change is just another way to talk about slope. Usually I refer to slope as rate of change when I'm talking about it in a real life situation where there are units. Okay, so we'll make ourselves a note that this is the same thing as slope. It's the same formula, change in y over change in x, y2 minus y1 over x2 minus x1. Okay, but we're usually going to have some units attached. So in example 4, the January sea ice extent for the northern hemisphere decreased approximately linearly, so giving us a clue that this is a line, and lines have slope. From, and let's look at our pairs here, so from 15.5 million square kilometers in 1979 to, decreased to 13.6 million square kilometers in 2006. So I'm just grouping my 2 sets of ordered pairs right there. In part A, I want to write down the ordered pairs. Now, when I write down an ordered pair, I need to make sure that I put the independent variable first. Okay, so the independent variable is going to have to be years, since the number of miles of ice extent will depend on the year. So we're going to have years as independent, comma, miles of ice. Okay. Now, I don't want to use just years as in years since 0. I want to be more specific on this, so I'm going to add a note on the bottom. I want to do years since, and sometimes I'm told in a problem what my starting year is going to be. If I'm not told, I get to choose what I want to talk about years since. It's often handy to either pick the first year you're given or to pick some handy reference, something that is close to that year. So if I had the freedom, I'm going to go ahead and just choose that first year since 1979 And that is going to make my first ordered pair 0, since that's 0 years from 1979, comma, 15.5. Now, I'll show in a moment that if you would have chosen 1970 or some other year close to this, you're going to get the same result for your slope, which is important to declare your year because that will affect what the ordered pairs look like. Okay. So, since 1979, so we want to talk about 2006. We'll just do a little quick subtraction here. We need to figure out what 2006 minus 1979 is. It's 27, so it's been 27 years. So my second ordered pair is going to be 27, comma, the 13.6. All right, so now we're going to calculate the average rate of change, which is going to be the slope. So we'll use our m for slope. And we know it's y2, which is the 13.6, minus y1, which is 15.5, over x1, which is 27, minus x2, which is 27, minus x1, which is 0. Okay. So again, just real quick on your calculator, 13.6 minus 15.5 is negative 1.9, over 27 minus 0 is 27. So if I divide by 27, I come out with negative 0.0703, so 0704 if I rounded to 4 places. It was negative 0.0704. Okay, now to make this an average rate of change different from a slope, what I need to do is just put it in a sentence and put my units back on here. So we're going to say that the sea ice is, well, first of all, because I have this negative in my slope, I need to say whether it's increasing or decreasing. So I'm going to say it's decreasing. By, now that I've already said the negative, I'm not going to write that in my number. So we're going to say by 0.0704, put our units back in. We know this is a ratio of y to x. Y coordinates over x coordinates. So y coordinates come first. Y coordinates had units million square kilometers. So by 0.0704 million square kilometers. And then the word most commonly used for the division is per. So per, and then the units, which are going to be years, so per year. Right? So my explanation right here needs to contain, especially the part increasing, decreasing. So this one was decreasing. It needs to have our value, and it definitely needs to have all 3 parts of those units. The per, again, being the word for division, which is a huge hint that you're talking about a slope, because a slope will always have a division since it's the ratio of y to x. Okay. All right, so I mentioned real fast that I was going to talk about the fact that I would get the same thing if I had started with a different starting year. So I'm just going to show that off to the side right here. If I had done years since 1970 instead, my ordered pairs would have been 9, 15.5, and let's try 2006 minus 1970, which gives us 36. So it would have been 36, 13.6. If I were to calculate this slope, I just want to show real fast it to get the same thing. So 13.6 minus 15.5 over 36 minus 9. Again, the top is going to be negative 1.9, and because 36 minus 9 is 27, you see that you get the exact same thing. So the difference in the x coordinates will be the same no matter what you choose for your starting year. It is important to pick a starting year though, not just use the original year value, because it's impossible to graph something that has such a large value on the x-axis. So make sure that you shrink the x values down, 0 and 27 or 9 and 36, something like that. Take a look at the example 5 on the next page. All right. In this example, D is going to be the distance in miles that a student can drive in T hours. And I want to create a scattergram, then draw the linear model. Okay, so time is going to be the independent variable, so I'll put that on my x-axis, and distance is going to be the dependent variable. The distance that they drive is going to depend on the amount of time since they started driving. Okay, so let's graph. The first ordered pair is 0, 0, so right here at the origin. The next ordered pair is 160, so a scale on this axis of going up by 1 is going to work. So 1, 2, 3, 4, 5, 6, 7, 8, etc. And on this axis, I certainly don't want to count by 1 because I would never get to 60. But it looks like if you check out these numbers that a scale of going up by 60 would be great, because 60 plus 60 is 120, plus 60 is 180. These are all multiples of 60. If you add 60, you're at 240. If you add 60, you're at 300. And if you add 60, you're at 360. Okay. What you have to make sure is that you're going up by the exact same amount right here. You can't have 360 and next have 370 if these are going up by 60 down here. They have to be the exact same amount every single time. Okay. And so let's draw the rest of our dots. We had one for 160. We need one at 220. We need one at 3, 180. Another one at 4, 240. And the last one at 5, 300. Okay. This looks like a perfectly linear equation. So when we draw the line, all these dots should line up perfectly on that line. Okay. Make sure when you draw a line that it always goes all the way out, because you might need to use that line as a model to make a prediction in one of the next parts. All right. First thing I want to do is find the slope of the model. Okay. We're going to find the slope first of all by the formula, and then we'll look at the graph and compare. Okay. So if I use the formula, I can take any of my 2 points and find the slope. Now notice that these are all exactly on the line. That way, that tells me that it doesn't matter which 2 points I choose. If this is a little bit off, I'd want to pick the best 2 points I could that fit the line that I drew. Right? So let's go ahead and choose, how about the first point, which is 0, 0, and 4, 240. We'll just pick a random point right there. Okay. So the slope, we're going to start with y2, which is 240, minus 0, over x2, which is 40, minus x1, which is 0. So you end up with 240 over 40, which if you divide that out should give you 60. Okay, that's the slope. And I want to verify that on the graph real quick, since I can count rise over run. So you're looking at any 2 points and you count from one to the next, the rise and the run. Remember that I need to use the units on this graph right here. So this rise right here, even though it's one box, is a difference of 60 over the run is a difference of 1. So that's 60 over 1, no matter which points you're looking in between. So I've got 60 over 1 from one point to the next, giving me my slope of 60. Okay. In part C, I want to talk about what does the slope mean in this situation. So back to putting units on the slope, making it a rate of change. So this right here, we're going to start with we're increasing because it's a positive. Something is increasing by 60, and let's put our units on this. I know it's a ratio of rise over run, so it's a ratio of y units to x units. So it's increasing by 60. The units on y are miles per, and the x units are hours. So if something is increasing by 60 miles per hour, 60 miles per hour is a speed. Okay, so we're talking about speed. I'm talking about the slope right here. Speed is the slope in this case. The slope is the speed, and the speed is increasing by 60 miles per hour. Okay, let's go on to the back of this page. In example 6, I want to find the slope of these two parallel lines. So we're just going to look at the slope by looking at the graph and comparing rise over run. So if I look for an ordered pair, it looks like there's one right here, maybe another one right there. So this one is going to have a rise of 2 and a run of 3. So the slope of the first one is 2/3. And let's look at the next one. The next one is going to have, let's see if I can find a point. There's one right here. And there's another one right here. Looks like a rise of 2 and and a run of 3. So this one's also going to have a slope of 2 over 3. So the conclusion is that if your lines are parallel, they're going to have the same slope. So parallel lines have the same slope. Okay. In example 7, I'm looking at two lines that are perpendicular. Perpendicular means that they form a 90-degree angle. And if my two lines are perpendicular, let's find out what happens with their slopes. So the first one, let's see if I can find, there's a point up here, another point right there. So if I look at my ratio of rise to run, it looks like I'm going down 1, 2, 3, 4, and over 1, 2, 3. So this first one is negative 4 over 3. And the next one, I found a point right there and another one over here. So that would be like this. So it looks like up 1, 2, 3 and over 1, 2, 3, 4. So this one would be 3/4. Okay. So there is a relationship between these two numbers. They are opposites because one is negative and one is positive, and they are reciprocals because the fractions are flipped. Okay. So perpendicular lines have opposite reciprocal slopes. Opposite means that one is positive while the other is negative, and reciprocal means that they are reciprocals of each other, which means that the fractions are flipped. So two things, opposite and reciprocal slopes. Okay, so we're going to use that information to answer example 8. If the slope of one line is 5/8, the slope of a parallel line would also be 5/8. The slope of a perpendicular line would have to be the opposite, therefore negative, and the reciprocal, so 8/5. Okay. If your line has a slope of 5, the parallel line will also have a slope of -5. And the perpendicular line would have a slope of, well, it had to be positive because it would be the opposite. And that would be the reciprocal of 5. 5 itself is 5 over 1, so it would have to be 1 over 5. Okay. If your slope is 0, the slope of the parallel line will be 0. And to be a perpendicular line, remember that 0 is going to be horizontal, so a parallel line will also be horizontal. A perpendicular line would have to be vertical in this case, so the slope of a vertical line is undefined. Okay. So I have to do that when I can't take the reciprocal of 0, because I would put 1 over 0, which again is undefined, it's not a number. All right, and that's the end of this section.